Now, in a pool, you need anywhere from 1 to 4 parts per million of chlorine. And in drinking water, you need anywhere from 1 to 4 parts per million chlorine. Who knew? We're all drinking pool water. Now, I'm from Montana, and it's a bit cold, but if you're from one of those warmer states, you might have a swimming pool in your backyard. A medium-sized one is 10,000 gallons. Now, you might want to know, how much chlorine do I need to add to my pool? Well, you need 4 parts per million chlorine. How much is that? Well, the world will never know. Parts per million is just something that no one's ever going to know. But as long as we start with it, or if we take something like percent and convert to parts per million, we'll be just right. Now, this equation up here, M1V1 equals M2V2, it's like the golden equation for chemists. It takes concentration, M, and volume, V. Concentration's in moles per liter. What's a mole? Well, it's a little critter that can fit in the palm of your hand. But we're talking chemistry. So what's a mole in chemistry? Well, it's a compound like sugar or salt. And 1 mole of sugar or salt, well, it'll fit in your hand. But then the volume. Volume can be in milliliters. It can be in whatever you want it to be. You can make it up. That's why I think parts per million are just made up. So you can multiply moles per liter times milliliter. How and why can you do that? Those units don't match up. Well, it's because you have the same concentration and the same volume on the other side. So it's like a ratio. So you basically can have whatever you want in these 2 slots as long as they match those 2 slots. So here's some examples. Concentrations can be moles per liter. It could be proof of alcohol, 100 proof. Or percent alcohol by volume. Like a beer, Bud Light, 4.2. Or 0.15. That might be like a percent too. That's like 15%. But it's just in its usable format, 0.15. Now here's a really small number. This was part of the other video. 4 parts per million, if you make it into its useful number, is 0.000004. Now again, it's a useful number, but humans don't like numbers that are small. Now if this was 4 trillion, I don't know any numbers bigger than trillion, but if it was 4 trillion, we'd be all excited about it. But because it's a really tiny number, we just use something made up called parts per million. So that's what that is. And if we want to make it up an even smaller number, we make parts per billion. Now our volumes can be gallons. Like our swimming pool is 10,000 gallons. Well, how much chlorine are we going to add? Are we going to add gallons of chlorine? I don't know. It doesn't sound like it. If rounded, volume can be pounds. Maybe if I'm adding pounds of salt, and I also know how many pounds of water are in my swimming pool. Today we're going to use cups. Not going to be too complicated. 16 cups in a gallon. 10,000 gallon swim pool, that's 160,000 cups. So that's what we'll use. Volume could be ounces, grams, milliliters, even drops from my last video. 70 to 75,000 drops are in a gallon. Alright, so how is this going to be simple? Well, this is the chemist equation, but simplified, you can just use C1V1 equals C2V2. This is concentration times volume will equal concentration times volume. The first step is to get all your concentrations the same. So I have, the second step is to get all your volumes the same. Then it's easy peasy. Our swimming pool is 10,000 gallons. We already converted that. We're going to use 160,000 cups. And our answer is going to be how many cups of bleach or chlorine are we going to put in our pool. Now our concentrations. Right now our pool has 0 parts per million chlorine. It's fresh water. So I bought some chlorine pool bleach, and it has 10% available chlorine. Well, how many parts per million is that? Well, 2 ways to get there. You can take 10% and put it into a useful number, 0.1, and then multiply that by 1,000,000 to get parts per million. So that's what I've done right here, and you get 100,000 parts per million. Or you can take 10% and just know that you're going to multiply it by 10,000. Now, if you don't know why you would multiply it by 10,000, then take 10%, get it back to its parts, its useful number, 0.1, and then multiply that by 1,000,000. That'll give you parts per million. And this chlorine is pretty concentrated. It's 10% pure chlorine. So that's going to be 100,000 parts per million. If our chlorine was 100% American pure chlorine, it would be 1,000,000 parts per million. But it's only 10%. So it's 100,000 parts per million. Alright, I think we're there. C1V1 equals C2V2. The concentration of the 10% chlorine, okay, that's 100,000 parts per million, so we write it right there. Our volume of that chlorine that we're going to use in our pool, we don't know that. But on the other side, the concentration that we want is 4 parts per million, and the volume of our pool is 160,000 cups. So there you go. Because these are parts per million on both sides, again, it can be any units. That's why parts per million can still remain one of the great mysteries of the universe. But we can use it and get to know what our volume, how many cups to use. Alright, so if you do the math, our volume is going to be 6.4 cups of that bleach we're going to pour in our pool. That doesn't seem like much, 6.4 cups, but there's 8 ounces in a cup. And that's 0.4 gallons. So that's a pretty substantial amount. If you have a large pool, like 20,000 gallons, you're going to add almost a gallon of this stuff. So that's just kind of good to know how much bleach you'll need to chlorinate a pool.